virtually everything, every single thing we're doing now wasn't even a remote gleam in the eye 40 years ago, because the LiDAR, which is a laser radar technology, was just in its infancy then. In fact, lasers were quite new. And the use of them to make radar-type distance measurements, you know, the way it operates. Instead of, a radar sends out radio signals and bounces off to get the information. We use laser signals that bounce off whatever is out there. And so we can measure, one of the easiest things to measure is how far away it is, that's the distance. And if you do that with a scanning laser, you can then do essentially what we're doing now is full three-dimensional images of what's out there with very high precision. We're talking measuring distances to within a few millimeters that ranges out to hundreds of meters, and making measurements in excess of 1 million times a second. So it turns out over these 40 years to one of the biggest advances is the ability to do three-dimensional imaging with very high precision. And of course, that's one of the main applications of that is for surveying. And we make our main business areas are to do with surveying, both from the ground, from the air, and in fact, if you choose your laser wavelength, the color, you can actually penetrate water. So we can fly over rivers and harbors and oceans and measure what's down there to depths of maybe 50 meters or so. And doing this at very high repetition rates and at large area coverage, 50, 60, 70 square kilometers an hour. So among other things, the LiDAR capability has just revolutionized surveying, totally revolutionized, and it's still going on. So, and we make a whole line of products and applications that provides survey applications. Many of them are very tightly focused and designed to do exactly what the customers want. So, I mean, you could do a survey inside of buildings, such as if you wanted to know where everything in this room was, you could do that. Or you can fly over in an aircraft and you can find all of the topography, you can find where the buildings are and measure them all and this sort of thing. So, and then the similar capability, of course, you convert all those to images. So a LiDAR image, scanned image, looks very much like a photograph, except instead of, in most photographs, the pixels are just two-dimensional, X, Y, if you want to say. Whereas with the LiDAR, we get the third dimension as well. So every pixel is located in 3 dimensions. And typically, in addition to that, we can get information on essentially the color of that pixel. So we really do have a revolutionary capability in 3D imaging. And of course, one subset of that is the surveying. And so we've pioneered in that, and things have changed. All of the basic technologies have just steadily improved over 40 years. I know everyone's aware now of the revolution in camera technology. It used to be to take a picture, you needed a film, and you'd take it to the drugstore and get it back in a week, and then you'd see if it was a good picture. Now, it's been said that more pictures are taken every single day than were taken in all previous history of humans. And that's true every day, which just means every day the number of, you think of all the teenagers running around, selfies, that's a brand new thing. Yeah, when I was younger, if you were taking pictures, they used to sell films for little cameras, and it would take 8 pictures. Well, you would go and you would buy the film, take 8 pictures, and then go and wait for a week and get the answer. So very small numbers of photographs were the norm. Now, well, I have granddaughters that take a couple hundred pictures, probably 100 selfies a day, So the whole thing has revolutionized, and the special additional capability of these LiDAR systems is that it brings in that third dimension. It really gives you a whole new 3D image. First of all, the specific goals are totally different. As I said, virtually every single thing we're doing now was just not even by the farthest stretch of imagination could you think of doing it. But on the other hand, there are things that we thought, yeah, we should be able to do this. It would be nice, because don't forget, for surveying, one of the big requirements, if you're doing airborne surveying, you have to know exactly where the aircraft is, and you also have to know exactly what it's doing, rotating and so forth. First of all, how to know where it is only came about in the early to mid-90s with GPS. Before that, you couldn't tell really where the aircraft was. And then in addition, the inertial navigation system, the ability to measure the movement of the aircraft. And so all of this has to be done and factored in so that if you know exactly where the aircraft is and exactly where the laser is pointing, and they know exactly the distance, then you can locate this point on the ground with very high precision. And that's what our systems do. But you couldn't even imagine doing that without having a GPS or an inertial navigation system. So that's the context in which you just couldn't imagine. And of course, the numbers of lasers, and since all of our systems involve imagery, cameras, as well as lasers, and as I say, the advances in camera technology has just been amazing. And of course, the other big requirement is memory. If you're making 1 million measurements a second, and each measurement carries a lot of information, you have to have a way of not only storing that and keeping it, but in processing it so you can feed back the intelligence that you get from the first shot if you want to do something on the next shot. So all of that is technology which didn't even exist. I was a professor at York University here for about 30 years, and students would come and say, you know, one of the questions, especially first, you say, well, what should I take to get a good job and for a good career? And I used to say to them, I'm not the right one to ask, because when I graduated with my PhD, lasers did not exist. They were invented the year after I got my PhD. Just by a quirk of fate, the first job I got was to take a look at lasers, because they were brand new. I was working with RCA, and they thought, we should have somebody looking at this. And I was a brand new guy, so they said, take a look. I've been working for 54 years on lasers now. I never had a course, in fact, the word laser didn't even exist when I got my PhD. So who am I to predict the future?
Right, yeah.
But really, we don't know what lies around any corner. Well, there's so many surprises in everybody's life. Certainly the main message for a student is you've got to be prepared, get a good skill set, learn how to learn, and then be ready to adapt to things as they change. And of course, that's what good students are still doing. But there's no easy way to predict the future, except it's going to be new, it's going to be fast, it's going to be better.
Yeah.
Well, today the UAV is, of course, relatively new. They have one form or another, have been around for a long time, but now they're getting smaller and faster and cheaper. And so they're just, certainly now there's discussions about having UAVs everywhere, doing everything. You know, send them off to the grocery store. It sounds a bit scary with all those.
Right.
Anyway, no, the future will definitely be exciting. It will be a lot of technical advances and many surprises. So we have to be prepared for surprises, not frightened by them.